Hi everyone. Today let's talk about session 3.2, Rules of Differentiation. Big idea. There is a trick called the power rule to compute the derivative of a power function quickly and easily without going through the limit definition of the derivative. The trick is that the derivative of a power function is equal to the exponent times the variable raised to the power of 1 minus the original exponent. So you can see we put the exponent down in front and then x to the exponent minus 1. Okay, so this is the rule. Big skills. You should be able to compute the derivative of polynomials, power functions, and linear combinations of functions using the power rule. So here, let's talk about different rules. So first, we have the constant rule. If c is any real number, the derivative of a constant function equals 0. Why is that? Think about constant function. Constant functions are horizontal line, right? So let's say this is 3. This is horizontal line, and what's the slope of the constant function? The slope is 0. So that's why we have the derivative of all the constant functions equals 0. And the power rule, okay, so we bring the power down in front and then x to the n minus 1. So we subtract 1 from the exponent. Okay, that is the power rule. And for constant multiple rule, if f is a differentiable function at x and c is a constant, then we can put the c in front, okay? Because we know derivative is like the limits, right? So when we have limits, let's say, okay, if we have limits c times f of x plus h minus c times f of x over h, well, you can factor out the c and then you can move it in front, right? So that's why we have the constant multiple rule. And for sum rule and difference rule, derivative of sum equals sum of derivatives. Derivatives of difference equals difference of derivatives. Well, that is because derivative is our, so if we have sum, so f of x plus h plus g of x plus h minus f of x plus g of x. Well, what can you do? You can distribute and then you can group them differently, right? You can group the first, this guy and this guy together, and you can group g of x plus h minus g of x. Oops, I ran out of space. Together, okay? Because you can group them together, okay? Addition is commutative and associative. Okay, so that's why you can group different terms together and add those first. So that's why you can break the sum and difference. However, derivative of products does not equal to the product of derivative, and the derivative of quotient is not equal to the quotient of derivatives. We will have product rule and quotient rule. We will learn this in next sessions, 3.3. Okay, so today we mainly focused on the power rule, and for derivative of sum and difference, we can simply just distribute and split them. The number e. So we know the e satisfies that the limits h goes to 0, e to the h minus 1 over h equals 1. So this is the property of the e, okay? It is the base of the natural exponential function, e to the x. And what is the derivative of e to the x? Well, that is e to the x plus h minus e to the x over h, right? But you can see e to the x plus h is e to the x times e to the h. Wow, what happened? Do you see the common factor e to the x on top? We can factor that out, and because it has no h, it's like constant compared to h, then we can put it outside of the limits. Then we have e to the h minus 1 over h. Oh, this is exactly this limit. It equals 1, right? It equals 1, so this is e to the x times 1 is e to the x. So that's why the derivative of e to the x equals e to the x. Okay? So far, so good, everybody. And last time, I also show you the GeoGebra projects. Do you remember which one? Let me see. Is this one? I show you that derivative is actually the slope of the tangent line at different points. And I show you that for exponential function, the derivative is actually the same as its original function. Okay. Let's see. I think this one. Okay, yes, this one. You can see the green line, okay, is e to the x, and the derivative is also the same. So if I don't draw it, so this is a green line, and I draw it. So this is the yellow, and they match. Okay. Let's continue. Next, after we learn those rules, let's work on these examples. So we want to find the derivative for the following functions. So before you differentiate, I suggest you to express them in terms of the standard form. What is the standard form? Well, standard form means I want you to express as like coefficient times x to the power of n. This is the standard form. So you can see 2x to the 6 is in the standard form. That's good. But 3x squared, we have a parentheses, so let's distribute it. The power becomes 3 squared, 9x squared. And this is 7 times x to the, because it's in the denominator, so it's x to the minus 1. And plus 5 to the 8. 5 to the 8 is actually a constant. This is actually a constant. It has no x in it. Okay, after you make sure all the terms are of the standard form, then we're ready to differentiate. Well, when we differentiate, the constant coefficient stay there, and the power 6, we bring it in front, and then x to the 6 minus 1, right? And then minus 9 stay here, constant multiple stay there, and then the 2, put it in front, x to the 2 minus 1. And 7, put the exponent down in front, and then x to the minus 1 minus 1. Well, this is constant. The derivative of a constant is 0. Okay, so what is that? Well, this is 12. 6 minus 1, 5. 9 times 2, 18. 2 minus 1, 1. So x to the 1 is just x. Then minus 7, x to the negative 2. So far, so good, everybody? Alright. So do you realize that if your x is in the numerator, the exponent is positive, when you take the derivative, what happened to the exponents? It actually decreased. See, 6. It was 6, now become 5. It actually decreased. It was 2, now it becomes 1. But if your x is in the denominator, what happened to the magnitude of the exponent? Well, this is the magnitude is 1, but it's in the denominator, right? But it becomes negative 2, so the magnitude becomes 2. So the number actually increased, but because it's in the denominator, okay? Yeah, so be careful with that. Let's continue. Part B. What is the derivative of t to the minus 6? Let me ask you. Is that equal to minus 6 t to the negative 7? No. Be careful here. We are having our variable is x. So variable is x, not the t. So if you give me a t, it's just like a constant. So in this case, the derivative is 0. Okay? Yeah, this part is a little bit tricky. So when you need to read the problem carefully. All right, let's continue. Okay, so here we have products. Okay, but we haven't learned product rule yet. So there must be a way that you can express it in terms of sum or difference. Well, we just distribute it, right? So we have 5x cubed. And let's figure out let's make it into the standard form first. Square root of 4 is 2. And then this is x to the 1/2. So I strongly recommend you to pause the video and try to work on it first. And then you continue to play it and check your work. Okay, so now we distribute. We have 5 times 2. When you multiply the terms, group the constant coefficient together. And then, so 5 times 2 is 10. And group the powers of x together. What do you do to the power? Do you multiply them? Or do you add them? So we add them, right? So x to the a times x to the b is x to the a plus b. X to the a to the b is x to the a times b. And then we have 5 times 3, 15. X to 3 minus 1. So what are these? This is 10. X to the 3.5, that is 7/2. And that is 15. This is 3 minus 1, 2. So I really hope that when you work on this, your homework and all the exams, try not to use your calculator. Build up the sense with the numbers, okay? You can use your calculator to check your work at the end after you finish the problem. Okay, but when you're working on the problems, don't use your calculator, especially when the multiplication and calculation is not that hard. Well, if you want to find e to the 2, probably you need a calculator, or square roots of 3, you might need a calculator. But for this integer or fractions, you don't need it. Okay, next, let's continue. So we have simplified and we're ready to differentiate, right? We have the standard form, now we can differentiate. The first term, 10, and then we have x to the 7/2, so 7/2, put it in front. X to the 7/2 minus 1 is 5/2, okay? Then 15 times 2, and then x, 2 minus 1 is 1. All right. 10 and 2, I can cancel the 2 and get the 5. 5 times 7, 35. X to the 5/2 plus 30x. So this is my derivative. So far, so good, everybody? Okay, let's continue. Well, the next problem, let's first simplify it. What is the 4th root of 81? 3. Yeah, if you build up the sense with number, 3 squared is 9, 3 cubed is 27, 3 to the 4th, 81. So 4th root of 81 is 3. Okay, so, and then x to the 1/4. Here, x to the minus 1, square root of 25 is 5. X to the, is it 1/5 or 5/2? 5/2. Gotta be very, very careful. So group the coefficient together. Group the x together. So this is 1. So remember, x to the a over x to the b is x to the a minus b. So 1/4 minus -1 minus 5/2. Okay, so what is that? That is 1/4 plus 1 minus 5/2. Well, that's 1/4 minus 3/2, right? Because -5/2 plus 1 is minus 3/2. Well, that is 4 is the common denominator. 1 minus 6/4. 1 minus 6 is -5. So -5/4. So far, so good, everybody. So then what is the derivative? Well, constant multiples stay here. Then the coefficient, we move it down, and then we have x to the negative 5 over 4 subtract 1. Oh, you can see the 5 cancel. So we can get negative 3 over 4, x to the minus 4 plus 5 is 9. 9 over 4. Are you okay, everybody? Okay, so when you watch the videos, you can control the pace, right? You can stop the video and then you can replay it again. Okay, this guy is a quotient, but we haven't learned quotient rule yet. So there must be a way that we can express it in terms of sum or difference. So actually we can split. So we can split as 3x squared over 6x to the 4th minus 5. Oh, this is like x to the 1/2, right? Divided by 6x to the 4th. And 3 over 6, that's like 1/2. And then we have x squared minus 4. Then 5 over 6, x to the 1/2 minus 4. What is that? 2 minus 4, negative 2. 1/2 minus 4. 4 is like 8 over 2. 1 minus 8, negative 7 over 2. So far, so good? So the derivative is 1/2. We multiply by negative 2, and then we have x to the negative 3 minus 5 over 6. We multiply by negative 7 over 2, and then we have x to the minus 9 over 2. Okay, 2 cancel, minus x to the negative 3. Negative cancel, so we have positive 35 over 12, x to the negative 9 over 2. So far, so good, everybody? So this is our answer. Some of you might ask, do we need to put this in the denominator? No, just keep it like this, okay? I would like to have the exponents on top, even though it's minus, that's fine. That is the standard form. It's very convenient because later on you might want to take the second derivative or third derivative, so it's good to keep the standard form, okay? So you don't need to move the x into the denominator, okay? Alright, let's continue. Example 2, find an equation of the tangent line of this function at the points. Well, right now, we're not asking to find the derivative using the limit definition, okay? So if the problem asks us to find the derivative or the slope of the tangent line by the limit definition, then we have to use the method we learned in section 3.1. But if the problem didn't ask us to use the limit definition of derivative, then we can use the derivative formula, which is like the power rule and the exponential function rule, okay? Yes. So when you do your homework and exams, you have to read the problem carefully. If the problem asks you to use the limit definition, then you need to use the limit definition. You cannot use the differentiation formula. Okay? So, alright, let's see part A. We want to find the tangent line, so we need to know the slope. Okay, so what is M tangent? So first of all, instead of finding M tangent, we should find the derivative, okay? So the derivative, 2x, derivative of 2x is 2, and then minus 1/2 stay here. Derivative of e to the x is e to the x. So this is the derivative. And then what is the M tangent? Well, we're looking at the tangent when the point A is 0, right? So it's like the derivative, we plug in x is 0. So we have 2 minus 1/2 e to the 0. That's 2 minus e to the 0 is 1. Oh, so we have 3/2. So this is the slope of the tangent lines at x is 0. Okay, so to find the tangent line, we need the slope. We also need the points. And we already have the points. Well, do you know what is minus 1/2? Well, this is actually f of a, right? When you plug in 0 in it, you get minus 1/2, right? This is f of 0. So we're ready. Y minus the y coordinate of the point, which is negative 1/2, equals the slope 3/2 times x minus the x coordinate of the point 0. Okay, so we have 1 plus 1/2 equals 3 over 2x. So y equals 3 over 2x minus 1/2. So this is the tangent line. So far so good, everybody? This is part A. Okay. So part B, we're looking for the point on the graph of f where the tangent line is horizontal. So here we have two directions. One direction, I give you the x values, and I ask you to find the tangent line. This is like a part A. Well, second direction is I give you the slope of the tangent line, and then I ask you to find the x values. So this is like the part B. Okay? So in order to find the slope of the tangent line, we need to know the derivative. We already know the derivative, right? But now we want the tangent line is horizontal. What does that mean by saying tangent line is horizontal? Horizontal means, what is the slope? Slope is 0. What is the slope? What slope is the derivative? Derivative is the slope, and we want the slope is 0. Don't plug in x is 0. See? Part A, you plug in the x is 0. Okay? Because you're looking for the tangent line at 0. But part B, you're looking for the points on the graph where the tangent line is horizontal. So your f prime is 0, and you want to solve for x. How do you solve for x? Well, we can add 1/2 e to the x on both sides. Then we have 2 equals 1/2 e to the 2x, and we multiply by 2x. We multiply by 2 on both sides. With 4 equals e to the. This is just e to the x. Alright, so after we isolate the exponential term, we can then, how do you get x? Apply natural log on both sides. So ln of 4 equals ln of e, and then ln of e cancel. So x is ln of 4. Okay, and we're looking for the points, not only the x values. So if x values is ln of 4, what is the y value? Well, f of ln of 4, you plug it back into our original f, right? So we get 2x, x is ln of 4, minus e to the ln of 4 over 2. But e and ln cancel. 4 over 2 is 2. So 2 ln of 4 minus 2. Okay, so the point is ln of 4 to ln of 4 minus 2. Okay, so let's draw some pictures. So what's the difference between part A and part B in our graph? Okay, so this might not be the exact graph. I just roughly show you what happened. Okay, so so it passed through 0 minus, so let's say this is minus 1/2, it passed through here. Okay, and let's say ln of 4, and let's say this is 2 ln of 4 minus 2, so we know it passed through this point. Okay, and so probably the picture looks like that. Okay, what is part A? Well, part A is asking the tangent line Okay, so it's asking the tangent line when x equals 0. Okay, so you're looking at the tangent line. So this is like part A. Part A is asking this tangent line. Okay, and we know the tangent line is 3/2 x minus 1/2. Okay, and then part B. What's part B? Part B is asking the slope when your slope is 0. Okay, and what is the point? Okay, this is the point. This point is ln of 4. Okay, oh, because there's only one x. I think my graph is not so accurate. So I know that we only have one point such that the slope is 0. So that's why we won't go back like this. So let me draw it again. So okay, click this back. Okay, let me draw again. Okay, so probably it looks like that. So far, so good, everybody? All right, let's continue. Example 3, let f be this function. For what values of x does the tangent line of f has the slope of 6? Let me ask you, which direction? Do you plug in x is 6 and then you find the slope and you find the tangent line? Or your slope is 6, you set the derivative is 6 and then you find the x? Which direction? The second one, right? So that's why here first of all we want to find the derivative. So derivative 3 times 2 6x squared. 2 times 15 30x plus 24. Okay, so we want to have the slope equals not 0, slope equals 6. Then we want to solve for x. Okay, so this is the slope. Alright, so how do we solve quadratic functions? We move all the terms to the left hand side. So we have 6x squared minus 30x. Well, 24 minus 6 is 18. Okay, and can you see 6 is a common factor? Let's divide it by 6. Simplify it. This is 5x and a 3. Can we factor it? Not really, right? 3 factors 1 and 3, it won't give you 5. Okay, so let's see. Let's use quadratic formula. Is 2a. I hope you can memorize quadratic formula, right? What's the formula? Is 2a, then negative b plus or minus square root of b squared minus 4ac. This is the quadratic formula. So 2a, a is 1, so just 2. Negative b is 5, plus or minus b squared, 25, minus 4ac. So 4 times 3, right? 4 times 3 is 12. So 25 minus 12 is 13. Okay, so we actually have two numbers. So here are the two numbers that x, the tangent line has the slope of 6. Probably, I guess, estimate, let's say, I want you to know, okay, let's say this is 5 plus square root of 13 over 2, and this is 5 minus square root of 13 over 2. So we have those 2 points, and at those 2 points, the slope is 6, right? So probably your let's see. Okay, probably it looks like this. Okay, then at this point the slope is 6. At this point the slope is 6. Okay, so I didn't graph the graph so accurate, but I can give you an idea at those 2 points. The slope is 6. Do you know what is the y coordinates? Well, if you plot those numbers into the f, then you can find the y coordinates. But we didn't do that, okay? But so roughly, this is the idea. At those 2 points, the slope is 6. You don't plug in x is 6, okay? When x is 6, I don't know whether this number is bigger or 6 bigger. But let's say if this is 6, when you plug in 6, you get a different slope, okay? You get a different slope at the point 6, okay? Alright, next. Higher order derivatives. Okay, so if f is a differentiable function, then f prime is also a function, right? If it's differentiable, then the derivative exists is also a function. So f prime may have a derivative of its own. We denote the prime f prime prime to be f prime prime. So the derivative of the first derivative is the second derivative. Okay? So assuming f can be differentiated as often as necessary, the second derivative is f prime prime. Okay, we call it f double prime is f to the parentheses 2. So be careful here. Parentheses denote derivative. If you don't have parentheses, if you just have f squared, this is just means f times f. Okay? So it's very important to have the 2 inside the parentheses in the exponent. Okay? So that equals the second derivative. Because it's like d dx of df dx. So that's why you can see there's 2d there. So the notation is d squared. And the bottom you can see there's 2 dx together. So that's why the notation is dx squared in the denominator. It's also the derivative of f prime of x. So in general, the f derivative is, this is a notation, d to the n f over dx to the n is the derivative of the n minus 1th derivative. So far so good, everybody? Yeah, it's also the same, the n minus 1 derivative. Okay? So that's why you combine this two. You get d to the n, and then you combine dx and dx to the n minus 1. It becomes dx to the n. Alright, that's the notation. Okay, let's look at example 4. Example 4, we want to find the third derivative of this function. Well, first of all, let's check all the terms in the standard form. Yes, right? Then we're ready to take the derivative. If it's not in the standard form, you have to change the function first. Okay? So 3 times 6 is 18. X to the 6 minus 1, 5. And then 27x derivative is 27. 5 stay there. Move the exponent down in front. And then x to the, that exponent's minus 1. Oh, negative 2/3 minus 1 is negative 5/3. And then the derivative of e to the x is e to the x, right? And then 2 stay there. Constant multiple stay there. Okay, so let's simplify it. So 18 x to the 5th minus 27 minus 10 over 3 x to the minus 5 over 3 plus 2 e to the x. Alright, how about the second derivative? Well, 5 times 18. 5 times 8 is 40 times 5 times 1, 5. That's 90 x to the 5 minus 1, 4. Derivative of a constant is 0. And then 10 over 3 stay there. Move the exponent down in front. X to the original exponent is minus 1. Then it's like 8 over 3, right? And then exponential function is still the same. Alright, so then we get 90 x to the 4th. Minus minus become plus. 50 over 9 x to the negative 8 over 3 plus 2 e to the x. Let's continue. Okay, the third derivative, you can write f prime 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 or f to the parentheses 3. But usually the fourth derivative, we won't write prime 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 prime. We only write the third derivative is the most we do prime prime prime. Okay, then the greater or equal to 4, we only use the notation f to the parentheses, the order parentheses. Okay. All right. Derivative of 90 times 4, 360, x 4 minus 1, 3. And then 50 over 9 times negative 8 over 3. X to the 8. So negative 8 over 3 minus 1. 8 plus 3, 11. Derivative, oh, e to the x is still e to the x, sorry. Okay. So that is 360 x cubed minus 50 times 8 is 400. 9 times 3, 27. X to the minus 11 over 3 plus 2 e to the x. Okay, so this is our answer. Do you have the same answer? Great. So let's continue. Next, for this problem, part A, we want to find the x value such that the derivative, the slope is 2, so the derivative is 2. Part B, find the tangent line and normal line. So what is normal line? Normal line is a line that's perpendicular to the tangent line at the points of tangency. Okay, so if you have a function and here, and that is the tangent line, well then, let's say this is 1. Then this guy will be the normal line. Okay, what's the slope of the normal line? If you can remember, if L1 perpendicular to L2, let's say K1, K2 are the slope, then what's the special about the slope? The product equals -1. So M normal is the negative reciprocal of the M tangent. Okay? That's the normal line. Alright, so part A, find the derivative such that the slope is 2. So to find the slope, we need to find the derivative. Well, x squared derivative is 2x. And then minus 6, right? So we want to set this guy equals 2. So then 2x minus 6 equals 2. 2x equals, we both sides add 6, we get 8. Or x equals 4. Okay? So, and it's asking x value, so it's enough to just find the x. If the problem asks us to find the point, you also need to plug in the function to find the y coordinates of the point. Okay? So part B. Okay, so part B. What's M tangent? Well, M tangent, we plug in 1 into our derivative. So 2 times 1 is 2, minus 6 is minus 4. This is the slope. To draw a tangent line, to write a tangent line equation, we also need the points. We know the x value of the point, that's 1. How about the y value of the point? We need to plug in f. Okay, so we plug in f. 1 squared minus 6 times 1 plus 5. So 1 minus 6 plus 5. Oh, well that is 0, right? Okay, what does that mean? Okay, so that means that point is at 1, 0. Okay, so y, our tangent line was tangent line. Y minus the y coordinates equals the slope times x minus the x coordinates. So y equals minus 4x plus 4. That is the tangent line. How about the normal line? Okay, normal line. What is m normal? Negative reciprocal of negative 4 is just 1 over 4, right? Then the normal line is y minus, so it's still passing through the same points, right? It still passed through the same points, but the slope change, okay? So y minus the y coordinate is still 0. And then the slope, x minus the x coordinates. Oh, so we have y equals 1 over 4x minus 1 over 4. So this is the normal line. Okay, so I'm gonna be careful, everybody. Your y coordinates might not be 0. Okay, if it's not 0, I'm so worried about the students make a mistake. I'm so worried about the students. When they write down the normal line equation, they just change this guy to 1/4 and keep the y-intercept the same. No, the y-intercept are not the same. So you can see this guy, they're not the same. So you have to start with the point slope form. They both pass through the same points, but the slope are different. Okay, yeah, you can see our picture. You see the y-intercept, they are not the same. So you cannot just change the slope of your point slope form. You have to start with the point slope form. Okay. You cannot just change the slope in the slope-intercept form. You have to go back to the point slope form and then change the slope and calculate and solve for y to get the new slope-intercept form. So far, so good, everybody. So this example is very good because it tells us there are two directions. I can give you the slope and ask you to find the x coordinates or x values, or I can also ask you to find the points. Then you also need to figure out what's the y coordinates of the points. So i.e., plot the x back to the functions after you get this guy. Okay. Second direction is I give you the x values and I ask you to find the tangent line and normal line. And then you need to find the derivative and then plug in the x values there and to find the slope. That slope is the slope of the tangent line. And then you also need the points. How do you find the y coordinate of the points? You plug your x into the function f. Okay, then you can get, so this is the y coordinates of our points on the graph. Okay, and then use the point slope form to find the tangent line. The m normal is the negative reciprocal of the m tangent. Okay, that is session 3.2. Okay, so have a nice day. Bye.